All right, let's go ahead and get started. So here we're presented with a triangle. Inside the triangle, I have labeled each of the interior angles as one, angle two, and angle three. Now, this is what's going to happen. I'm going to go ahead and create an extension to the base of my triangle. The base of my triangle is this bottom part. So that I'm able to then see, let me go ahead and repeat that so you guys can see it in slow motion. The extension is going to add a little bit more length to that bottom, that base to our triangle, so that we were able to see this new ray that's created. And it's adjacent to our triangle, right? It's adjacent right next to or it's part of our base. And I'm going to go ahead and just focus now that I've created that base in this exterior angle that is created by that extension. Now, I'm going to go ahead and, annotate it by signifying its measurement. And that's what we're going to go ahead and create or call as an exterior angle. Now, an angle that is adjacent to it is angle 3, which is inside of our triangle. We also have other two interior angles that are inside of our triangle. We're going to go ahead and call angle 1 and angle 2 in this case remote interior angles. Remote interior angles means that they're angles that are not directly adjacent to that other exterior angle that's created by the interior angle and that extended side. So here's the definition of an exterior angle. And according to our text, it is an angle that is formed by one side of a polygon. In this case, we have a triangle and the extension of an adjacent side. So here is the exterior angle. And remember that we have two remote interior angles that we're going to go ahead and also focus on today. I just want to introduce you the exterior angle. Go ahead and copy this down so you can have it in your notes. And we have our official definition. Now, my question here to you is, how can we find the measurement of an exterior angle or of a triangle? Yes, we can go ahead and apply this to any polygon. Remember that in our previous lesson, we were able to construct many triangles instead of a polygon. The same application can be applied as well. We can go ahead and first apply it to a triangle and then to a polygon so that we can go ahead and see that we have triangles instead of our polygons. But how can we find the measurement without having a protractor, without having any type of measuring tool to measure angles in real life? I'm going to go ahead and demonstrate. With that said, I'm going to go ahead and create some magic and demonstrate physically how you can do it. This is going to give us now our next theorem that we're going to be seeing and applying to our examples. But we're going to go ahead and prove it instead of using a 2-column proof, a paragraph proof. I'm going to go ahead and prove it in real life so you guys can see. I hope you guys can see it. Okay. With that said, is it still recording? Yes, it is. Okay. Awesome. So here I have my camera. It's facing my docu camera here. And let me just fix it so it's right in the center. Awesome. So here I'm going to have a figure that we have. This is what we call a triangle, if you didn't know. Just kidding. All right, I'm going to go ahead and label my angles so I can see what's happening. Let's see. Let me turn it this way so you guys can see it the same way. So here, I'm going to go ahead and label this angle. I'm going to start from the top. Angle 1. This is my angle 2. And this is my angle 3. I have to write it backwards because my camera, for some reason, it's backwards. Now, I'm going to go ahead and create that extension with my ruler, of course. That extension to the base of my triangle. just how our definition, so that we are able to create that exterior angle. Here it is. Imagine that it's nice and straight. There you go. Beautiful. Here's that extension. I'm going to go ahead and place my triangle directly on my paper. Now, once I've created that extension, we can go ahead and identify that exterior angle, that angle 4 that I created. So here is that exterior angle. Here's my interior angle 3. This is what I now call my remote interior angle. And also remote interior angle, right? These are my 2 remote interior angles. And I apologize that I have a screen mirror image of it. I'll try to see if I can reverse it. But this is what I'm going to go ahead and do. This is my magic. Here is my exterior angle. Here is the angle that is adjacent to it. Here are my 2 remote angles, meaning the angles that are not sharing a side with either of these 2. I'm going to go ahead and first remove my first angle, interior angle from my triangle. Bear with me. Ms. Vasquez, you're destroying your triangle. Yes, that's intentionally done. I'm going to go ahead and place it here. And I'm going to go ahead and do the same, but now for my angle 2 on my triangle, my second remote triangle. And I'm going to go ahead and place it here. What do you notice here? Well, I see that I have a straight line. And I hope to notice that whenever I have a straight line, its measurement is 180 degrees. Well, I already have the measurement of angle 3 there. I have angle 4 that I've created outside of my triangle. That's my new exterior angle. And I've removed angle 1 and placed it right on top of angle 4. And I've done the same with my angle 2 and place it on top of angle 4. So what can I say about that last triangle, my exterior angle 4? Well, if you notice, when I remove them and I place them directly on top, try my best here to keep these 2 together. They're exactly the same measurement, if you've noticed. Measurement of angle 4 is the same measurement of angle 1 and angle 2 put together. Wow. So what can we say? We can say that whenever we add the 2 remote interior angles, meaning angle 1 and angle 2 together, it will give us the sum of that exterior angle, angle 4 in this case. All right. Let me go ahead and place it once again and remove it so you guys can see it. Angle 1 plus angle 2. Add these 2 measurements, angle 1 and angle 2, will give us or make it equal to the measurement of that exterior angle, angle 4. Awesome. So where does this take us? It takes us to our definition now, or to our new angle or theorem that we have here. It's what we called our exterior angle theorem. And it states that the measurement of the exterior angle of a triangle, we're focusing here on triangles, is equal to the sum of its measures of the measures of its remote interior angles. So notice here that I've supplied you with the same diagram that I have here on my camera whenever I did my little removal of angle 1 and angle 2. And we're able to see that whenever we have angle 1 and angle 2, it's measurements. We're going to go ahead and add them together. It's the sum and make them equal to that exterior angle. That's why it's important to be able to identify the remote interior angles first. Then we can go ahead and see what that exterior angle measurement is. Or vice versa. What if we're given the exterior angle measure and we're trying to find either or of the remote interior angles? It's going to help us apply it and find out what their values are. Okay, go ahead and pause this video if you need to copy this down. Here is an example of what or how I would write an equation to represent this particular example. Notice that in other examples, we'll be given letters for vertices and we'll be given different angle measurements as well. Okay, so here we go. Example number 1, it says, given the measurements of some interior angles, find the measurements or find the missing measurements for the exterior angles using the exterior angle theorem. Now, how do we do this? Let's go ahead and find out. Let's recall some information first before we move on and actually apply the exterior angle theorem. Why do we need to know that? Because we need to know the measurements of our angles inside. If you guys recall, the interior angle or the triangle sum theorem, it states that whenever we have angles inside our triangle, their sum is going to equal 180 degrees. So let's go ahead and write that out. We know whenever we add all those three together, it's going to give us 180. Well, one of the angles that we have inside of our triangles is missing. It's being represented by X. Now, how do we find X in this case? Let me do that. So I'm going to go ahead and write my equation. I know that their sum is 180 degrees. So how do I write it out? Let me go ahead and have my tool. I know that there's sum. So I'm going to go ahead and add all three of them. Here I have the measurement of angle X plus the measurement of angle 50. Or I'm going to go ahead and go on to the next one. 43 plus 55 degrees equals 180. From here, let's simplify. Okay, so I have X plus 90, let's see, 8 and 5. Sorry, 3 and 8 give me, 3 and 5 give me 8. There you go. Equals 180. Subtract 98 on both sides. X will then equal 82 degrees. Correct. Okay, so this one will be 82 degrees. Now, once we have that information, we can go ahead and solve for each of the exterior angles that we have here. Measurement of angle 4, measurement of angle 5, and measurement of angle 6. Okay, so let's go ahead and do that. Let me create that space. So here I'm going to go ahead and do angle 4. Measurement of angle 4. Here the measurement of angle 5. And lastly, measurement of angle 6. So here we have, let's see, measurement of angle 4. So how do we find measurement of angle 4? Let me go ahead and do this one in blue so you guys can see it. Here is angle 4. Our first exterior angle that we have here. So measurement of angle 4, we said that it had been, or it's the sum of its remote interior angles. Sorry about that. Remote means that it's the other two that are not directly adjacent, meaning that they're not sharing that side or that vertex for that case directly inside of our triangle. So here we have X as our first remote interior angle, and this angle here, measurement of 55. So let's go ahead and write that out. It's fast because we already know the measurement of angle X. Okay, so let's go ahead and substitute that. Measurement of angle 4, here it goes, 82 plus 55. So let's see, measurement of angle 4. If we continue to simplify, 82 plus 55 should give us 137 degrees. All right, so we have our first angle. Let's do the same now for angle 5. Let me go ahead and do this one in green. So here's angle 5. Let me go ahead and erase this, erase this. Let me then identify its remote interior angles. There's 2. Here is X again, and this time it's 43. Let's see, so measurement of angle 5, 5 equals X plus 43. All right, so let's see, simplify. It's fast because we know the value of X. So let's go ahead and substitute that. 5 equals, measurement of angle 5 equals 82 plus 43. Measurement of angle 5 should give us 125. Awesome. Degrees. All right, last one. Let me go ahead and do this one. And let's see. Let's see if we can see orange. Yeah, orange is visible. Okay, so let's go ahead and identify its 2 interior remote angles. So here's my angle X. Here's angle 6. Our next 2 interior remote angles are 55 and 43 in this case. So let's see, measurement of angle 6 equals 55 plus 43. Measurement of angle 6 in this case. Well, we already did that, 43 and 55. 98 degrees. Awesome. Okay, so this is finding directly exterior angles, practicing so that we are able to identify first its remote interior angles, depending which one we're trying to find, and noticing that the relationship is that they're the sum of those 2, right? So we add those 2, and it equals that exterior angle that's created when we create that that extension. Only when we create that extension. If we don't create the extension, then it's a different type of exterior angle. But right here in this case, we're just dealing with that extension and its measurement, right? Okay, so let me go ahead and clear this out. And let's go on to example number 2. It says, given the image below, determine the measure of angle PRS in triangle PQR. I'm going to go ahead and do this very quickly. Okay, so example 2, we're given an image below. It says to determine the measure of angle PRS in triangle PQR. So how do we find that measurement? Let's go ahead and first identify that angle. Here we have to determine the measurement of angle PRS. There's PRS inside of our, or in our triangle. So where is PRS? So PRS. All right. This is where our angle is located. Let me go ahead and just retry it. Because I'm trying to include my my expression that's written for PRS, sorry. And PRS has an expression. It's 3x minus 8 in this case. Well, if we were to continue to use that exterior angle theorem, we're told that whenever we have that exterior angle, its measurement, it's equal to the sum of the 2 remote interior angles. So here's our exterior angle. Here is that that extension to the side. And if we're to identify those 2 remote interior angles, here we are able to identify that Q is our first remote angle, and also P is our second remote angle, interior angle to our triangle PQR. So let's go ahead and write down an equation. So measurement of angle PRS equals to the sum of these 2 angles. There you go. My plus sign, not my multiplication sign. I'm adding those 2. So measurement of angle Q plus measurement of angle P. Let's go ahead and substitute their values. Well, PRS represents this expression, 3x minus 8. Measurement of angle Q, if you notice, it's implied. We're told that it's 90 degrees. And measurement of angle P is another expression, x plus 2. Okay, let me go ahead and redraw this part just because I don't want you to confuse that with another x. That is plus. Okay, so let's go ahead and simplify and solve for our variable. Let's see, here we have 3x minus 8. This side is already simplified. Over here, we have to add 90 and 2, so x plus 92 degrees. Let's go ahead and continue to solve for x. What do we do? Subtract x on both sides. This goes to 0. We're left with 2x minus 8 equals 92. Add 8 on both sides. This gives us, let's see, 2x equals 100, because 92 plus 8 is 100. Divide by 2, divide by 2. Our value for x here is 100 divided by 2, 50. All right. Now, are we done yet? Are we done? I hope you're able to answer this question. And the answer to this question is no, we're not done yet. We still have to find that measurement. It's asking for that measure of angle PRS. So we already had identified that angle. It's 3x minus 8. Well, do we know what the value of x is now? Yes, we do. So let's go ahead and find that out. Measurement of angle PRS equals 3x minus 8. Well, we said that x equals 50. So let's go ahead and substitute that into our expression. 3x times 50. Goodness gracious. Minus 8. 150 degrees, or 150 minus 8. That gives us 142, if I'm not wrong. Yeah, 142 degrees here. So the measurement of angle PRS is 142 degrees here. All right. Awesome. So take it step by step, identify that exterior angle. Remember that its measurement is equal to the two interior remote angles inside of our triangle. Remote are the ones that are totally not adjacent to it. They're not sharing a side. So if you need to draw those arrows, do so you can go ahead and see the remote angles. Once you have the value of x, you can go back and substitute your value into the expression to which your angle is equal to. If it's equal to an expression, then you can go ahead and find that value, right? That measurement to that angle that you're trying to find. Okay, so for exit ticket, you have another example. This time you're trying to find the angle of M and P, and you have your triangle given, triangle M and P. And just take in consideration that this time you're not trying to find the measurement of the exterior angle. You're trying to find the measurement of M and P. M and P. So you're trying to find the measurement of this beautiful angle. So go ahead and do that as an exit ticket and have fun.